Assalamualaikum guys, today we discuss the next half of the D block element. We discuss the third property in ionization enthalpies. In a series from left to right, the ionization enthalpy increases due to increase of the nuclear charge. The regular trend in the first ionization enthalpy of the 3D elements, though of little chemical significance, can be accounted by considering the removal of one electron alter the negative energies of 4s and 3D orbitals. The oxidation state, they show variable oxidation state due to the two incomplete outermost shell. Only stable oxidation state of the first row transition metals are from scandium to zinc. The transition metals in their lower oxidation state plus 2 and plus 3 usually forms ionic compounds. In higher oxidation state, these are usually covalent. Only osmium and ruthenium show plus 8 oxidation state in their compounds, and nickel and iron in nickel complex and iron pentacarbonate show 0 oxidation state. Trends in standard electrode potential. The transformation of solid metal atoms to M plus 2 ions in solution and their standard electrode potential. If sum of the first and second enthalpies is greater than hydration enthalpy, standard potential will be positive and reactivity will be lower and vice versa. Trends in stability of higher oxidation state. The higher oxidation number are achieved in titanium X4 to chromium F6, and the plus 7 oxidation state of manganese is not represented in a simple halide, but MnO3F is known, and beyond MnO, no metals have a trihalide except FeX3. Magnetic properties. When a magnetic field is applied to substance, mainly two types of magnetic behavior are observed: diamagnetism and paramagnetism. Paramagnetism due to the presence of unpaired electron, an electron having a magnetic movement associated with spin angular momentum. The magnetic moment is determined by the unpaired electron equal to the under root of n plus 2, where n is the unpaired electron number of unpaired electrons, and if all electrons are paired, the substance will be diamagnetic and magnetic moment will be 0. The number 8 property of the D block element is the coloration property of ions. The D block elements are non-degenerated in the presence of ligand. When an electron is from a lower energy is excited to higher energy level, the energy required wavelength is absorbed and the red light is transmitted out. So the color is observed. There is a complementary color of the light is absorbed. In V2O5, for example, is a plus 5 oxidation state. It is colored due to the defects in crystal lattice. The ninth property is the formation of complex compound. They have very small size, high nuclear charge, which facilitate the acceptance of lone pair of electron from ligands. They have vacant d orbitals of appropriate energy in order to accommodate the lone pair of electrons. Number 10 property is the catalytic property. They have the two outermost shell incomplete and ability to adopt the multiple oxidation state to form the complexes, and these are used as a catalyst. So transition metals also provide larger surface area for the reactant to be absorbed in the catalysis process. Formation of interstitial compound. Small size of non-metals carbon, hydrogen, and nitrogen. They fit into the wires of crystalline solid of transition metal and then form the interstitial compound. The principal physical and chemical characteristics of these compounds are as follows. They have high melting and boiling points than those of the pure metal. They are very hard. They retain the metallic conductivity and they are chemically inert. The last property of transition metals is the homogeneous mixture of two or more metals. Transition metals have appropriate same size, therefore in molten form, that can fit into each other and form homogeneous mixture and again form the alloys. Alloys, brass is the example of alloys, which is a mixture of copper and zinc, and bronze is an alloy of copper and tin.